So test. Okay. So good morning all, and thank you for joining this session. So my name is NUNO CRUZ. So this is fourth day I've been here. So I've met many of you before, and we have the chance to talk a little bit. So, but the topic of this short talk is on the need for standardization. But since I'm here, also planning to have collaborations and discussions with other people. So I put here a little bit of a presentation, 5 minutes presentation of our lab, what we do, and it explains a bit why we are joining actually this project and this problem of data analysis from marine observatories. Who am I? So my background is electrical engineering, and I work in robotics, so a little bit away from these observatories. Actually, as Rui pointed out, observatories are usually in a fixed place. Obviously, if you expand the concept, you start having vehicles that can move around and integrate data that's away from this observatory. So this is what I've been doing for, well, I don't want to talk about it, for many years, let's say. So working in robotics, first was with other people's robotics, mainly in the United States, but since the 2000 or something, we started having our own vehicles in our lab. So this is just to see that we are in the right spot. So we are more or less halfway between Haifa and Porto. So we are here in the middle. So this is just a location that we want really to learn, particularly what's going on in the Mediterranean or close to the ocean. So this is where we are. If you happen to travel that way, just let me know. I'll be happy to show you around. Also a bit of motivation. So this is the size of Portugal. So you can see the little yellow part in there, that's our mainland. But the area that we have under our, let's say, protection, it's huge. So it's over 40 times our land area. And as you imagine, we don't know what's there. So it's really, we have really a lack of knowledge of what's going there. And we have many places beyond 4,000 meters of water. And we have been sampling it for a long time, but as you know, sampling with an oceanography vessel, you get a speckle there, so it's just a little point. So it means that we really have many opportunities for robotics. That's where we fit in. We cannot complain with having many projects in terms of robotic application for the sea, and there's a lot to be done. So my institute, so I have two shirts, let's say. So I teach at university. I have this INESG-FER shirt now today, so I'm almost a salesman now. So what's INESG-FER? So we can see this all in many places of Europe. So it's just an interface institute. So we overcome some of the, let's say, problems of bureaucracy working with the university. So we have this university, he's a shareholder. So it's a good match between what we can get from the academia and what we can apply to problems and to companies' needs and society in general. And in terms of size, I'll skip this. So we are hundreds of people. Actually, this is outdated. We are close to 1,000 now. But let me go more into how we divide ourselves. So we are an engineering institute, and I've underlined there the robotics and autonomous systems. That's where I work. So we divide into these areas of engineering. So there are many, as you know, from communications, computer science, related sensors, physicals. So all that we divide these people, and so my center, we call it centers. My center is a Center for Robotics and Autonomous Systems. And in terms of size, we've been growing quite a lot. So we started this INESG-FER group, let's say, 12 years ago. And as you can see, we've been growing steadily. The number itself was a bit, I think it's a bit important, so over 60 people. But what's very important for us is the lower part, that we've been increasing steadily the number of, let's say, fixed researchers. So those are very important, because if you have new projects, you can have new grants, so you can have more hands helping. You can have PhD students, you can have many, shorter-term projects. But it's important to have a team that stays with us for many years. And we can get that. We have two ways of having that. Either it's through faculty members like myself, or we can have specific contracts so INESG can have a career, can provide a career for research contracts. And you can see a few gaps, especially in 2014. The gaps are usually in the part of the grants, because it happens sometimes now, like it's happening now. A lot of demand from industry, so they contract our grantees. So it's difficult to fight that. At the same time, sometimes we have projects are finishing, so it's a bit of a things that we need to be. We are getting better at it now. We have a more sustained system, and I think we're not growing much more than this. So I think the kind of projects that we have and we want to have, I think we have a good number. So something like a little above 50 people. And in terms of facilities, so we have quite good facilities, I would say. As I said, you are welcome to visit anytime you get close to Porto. So we have quite a large lab space, and we have one thing is very important, space for experimentation. So we have these 2 tanks. So one is 10 meter by 6 meter, the top one over there, 5 meters deep. So it's quite good for testing robotic systems or systems that go into water in general. We have a smaller one, and the best thing is that now we also get facilities right on the port. Well, Porto I didn't say. So Porto is a city very close to the sea, but our lab is like 5 kilometers away. So it's not that much, but we like to have these facilities right on the sea. So we have a small reef. Now we have a larger vessel. That one is just delivered. So it's a 19-meter vessel, much cheaper to operate than a traditional oceanographic vessel. So to give you an idea, you may know that you cannot get any oceanographic vessel for less than 10,000 a day, and we are having this one between. It depends on what we do, but maybe about 3,000 per day that we can have. And of course, the Atlantic is rough. So we are in the Atlantic. The Atlantic is rough, and this ship is designed to be available on average 150 days per year. That's what we plan. And it's available for the community as well, so we can have a program for interaction. So, and finally, we have robots, of course. We have this Center for Robotics and Autonomous Systems. We have many robots. So we've been developed forever. Well, we have more than these, of course. This is just an example, and I will talk a little bit later about some of these and how they can be used. So what we use the robots for? We use robots because, well, of course, many of us have quite some fun developing them, but they are tools to get data. Okay, and now the subject of the talk. So we have data, but then what we face is that many times we have this teaming with geologists or marine biologists or whoever needs this data. So we took their sensors, we integrate their sensors, and we provide them the data. But we always have this issue how to provide data. So we found this early. That there's not, let's say, a standard for the data that people want. So I think this is more or less obvious for everybody. So, but what we'd like to stress here is that if you look at any marine observatory institution or managing institution, they have their own standards. So you go to Timor, you go to Neptune, they have their own standards. Either if it's just a buoy or a set of buoys, or if it's a distributed system like Neptune or something, or even if you have something that incorporates data from vehicles. They always have their own way of designing the way to store the information, how to provide them, how to download if you want to download packages. But that's one thing if you are, as I said, with a single institution that's managing. The problem comes in this last part here. So what happens if you are an oceanographer or someone that wants to study this in a global sense? Then you have to get data from multiple sources. And if you want to get data from multiple sources, you jump into these issues of how is this data provided. So what I'm talking about, so people sometimes say, well, it's obvious, you just use SI units, you know, or standard units for pressure, for temperature, salinity, turbidity. Of course, that solves part of the problem, but that's not the real problem when people are integrating data. The problem is that what is the metadata that you have in our data sets? What is the quality, let's say, score of that data? How were the sensors calibrated? Can you trust that data? You see, how was it taken? Was it in a moving platform? Was it in a fixed place? If it was in a moving platform, how was the sensor installed? what is being affected by something, for example, power supply on the UV. These kind of things, they are not usually discussed. And those will matter, especially when you're talking about, for example, global warming. You are detecting something that's really small. So you are detecting trends. And the slight change in your quality of data can affect the conclusions that you get. And here I put a print of a website, and this print was, I think, last week or something. It's interesting because it's an initiative from UNESCO to try to standardize things. So this is actually a website available, Oceans Data Standards, where you see some discussions on this problem. But I put this here just to highlight two things mainly. One is that the last news entry here is like 1 year old. So September 2020, okay? But more than that, if you look, and this I didn't cut anything, if you look the 5 or 6 of them, they span 12 years, okay? 12 years. So people have been discussing this forever, so it's a good thing. So it's a problem people are trying to address. The bad thing is that we don't see any good outcomes out of this. So what can we do? So the thing is that we know that this has to be like this top-bottom approach. So some strong organization has to define these standards. But we also feel as a community, and we are all here in the same page, let's say, we can also have a role if we can try to provide it as a bottom-up approach. So I mean, if people really trying to organize in a way that try to standardize procedures, try to standardize the way that data is treated, we can have this kind of de facto standards. So standards by being used by many people. And I think that we have to mix this, otherwise we cannot spend 10 years waiting for some standard. And so the middle point here is that, so we are in a stage that we have already many people taking data from observatories, moving or fixed, and we are trying to address this through the Qualtus project. The Qualtus is the project that we have together, small project, but it's a good tackling this problem, highlighting some of the difficulties, and we are targeting this in 2 ways. One is to have some standardized, let's say, way of tagging the data, either it's good, bad, how good it is, and also trying to employ this new technology with using AUVs to avoid taking people for calibration, and that's what I'm going to talk later on. Okay, so this is just an introduction. Stay tuned. I put here questions, but I think we'll have the questions on the discussion part. So I think we can proceed, and thank you for your attention. Okay.